In the stillness of an ancient twilight, a question has echoed through the corridors of human thought. Who truly determines the gender of a baby? Is it solely under the influence of the man's contribution? Or does nature conceal deeper, intricate secrets? This inquiry, as old as humankind, invites us into a world where the rhythms of biology and chance compose a complex symphony. Today, we embark on an exploration that penetrates beyond the surface of common explanations, venturing into the microscopic realm where the ultimate decision is written in chromosomal code. Our journey finds its human element in a hopeful couple eagerly awaiting their first child. Their eyes reflect not only anticipation but also an unspoken curiosity about one of life's most profound mysteries. They represent every family whose dreams are interwoven with advanced scientific narratives. A narrative that stretches far beyond the confines of hospital corridors and clinical settings. The secret, as we now reveal, resides deep within a biological arena that unfolds far from our usual view. A domain governed by genetics and biochemistry that challenges our understanding with precise molecular determinism. As we transition into an imaginative, microscopic landscape, the scene transforms into an expansive and vivid interior of the female reproductive system. Here, the environment is as dynamic as it is enigmatic. A lush, living milieu composed of tissues interlaced with molecular signals, where millions of sperm embark on a formidable journey. Amid this enormous congregation, every individual cell moves with a defined purpose. Yet within this vast assemblage, two types of sperm emerge as central players: those carrying the X chromosome and those bearing the Y. This duality establishes a race that is both scientifically measurable and rich with biological narrative. The revelation deep within this microscopic world is as elegant as it is decisive. Scientifically, the gender of a baby is determined by the man's sperm, which carries one of two possible chromosomal payloads. Every egg, contributed by the woman, consistently harbors an X chromosome. Hence, fate hinges upon which sperm reaches the egg. If an X-bearing sperm unites with the egg, the embryo develops as a female, XX. Conversely, a union with a Y-bearing sperm results in a male, XY. This dichotomy is supported by decades of research in cellular biology, genetics, and reproductive physiology, all converging on the fact that the determinate power lies within the contributions of the sperm. Visualize the moment as a thrilling race between two finely tuned contenders. The Y-carrying sperm, characterized by being lighter and faster, races ahead in what can be seen as a sprint propelled by its streamlined structure. However, its speed comes at the expense of durability. In contrast, the X-carrying sperm is generally slower but demonstrates enhanced resilience, with a stronger constitution capable of surviving in a demanding microenvironment over an extended period. This competition, seemingly simple, is amplified by the underlying biological physics and chemistry, creating a vivid interplay of speed and endurance that determines which chromosome ultimately crosses the finish line first. Peering deeper, the outcome of this microscopic race is not decided purely by intrinsic differences between the sperm types. Several nuanced factors come into play, each adding layers of complexity to the process. The timing of intercourse relative to ovulation establishes a temporal window wherein the competitive dynamics shift. Within the reproductive tract, the local environment, including factors such as pH levels and mucosal properties, exerts chemical influences that favor the survival and mobility of one sperm type over the other. Additionally, the inherent lifespan of each cell in this journey further complicates the scenario, as the relative endurance of X-bearing sperm can provide a competitive edge under certain conditions. Each of these variables is meticulously orchestrated by natural biophysical laws, an interplay that continues to captivate researchers who study reproductive biology with ever-refined analytical instruments. At the climax of this biological expedition, the moment of fertilization unfolds with an almost cinematic tranquility. In this precise instant, one single sperm, bearing either an X or a Y chromosome, successfully engulfs the egg. The encounter, occurring in a realm invisible to the naked eye, simultaneously marks the cessation of an intricate journey and the beginning of an entirely new human narrative. The union of gametes represents more than a mechanical interaction. It is the culmination of competitive dynamics, delicate chemical balances, and a convergence of genetic information that will shape the future of life. The scientific truth resonates in this singular event, where the eventual genetic blueprint of the future individual is irrevocably determined. In reflection, the journey through microscopic arenas and genetic debates reaffirms that while science meticulously deciphers the steps leading to gender determination, it does not diminish the inherent wonder of life. The process, governed by an array of precise natural factors, from cellular velocities and molecular survival times to the nuanced chemistry of the reproductive tract, reminds us that deeper mysteries persist beneath every scientific revelation. Ultimately, the gender of a baby is decided not by human decree, but through a delicate balance of biology, timing, and the tremendous journey of a single cell that truly encapsulates the marvel of human creation.